All right, so welcome to Progressive Web Apps. So by the end of this lesson, you should be able to describe the benefits of progressive web apps, and you should be able to intercept network requests with Serviceworker. So let's start on this first objective, describing the benefits of PWAs. I am going to link to an article I'd like you to read. Take a couple minutes and read through that. Those are the 8 or whatever things that define progressive web apps. All right, holler at me when you get to the bottom.
Okay.
Cool. So right off the bat, what questions do you have from reading that?
Um, so installable,
Mm-hmm.
this sounds like this could completely replace the need to build something out in like a React Native platform. Is that correct?
Correct. This is
That's
a
baller.
one-for-one replacement with native applications.
Why are we not doing this all the time?
So, for one, this idea is about 3 years old or so, is when we started getting some of these technologies. But it wasn't until, let's see, when did Safari add Service Worker? August of 2019. So this isn't even a year ago.
Oh,
Safari was a massive holdout on a really critical technology for making this stuff happen. Um, they were also really opaque about it. So for a while, it wasn't like, well, we're working on it, but we don't know what day we'll have it ready. It was, we don't know if we're going to do it. And so the entire rest of the industry was like, well, if it's not on Safari, this is kind of dead in the water, because that also applies to Safari Mobile, which you may or may not be aware is all browsers on iOS. Like if you use Chrome or Firefox, you're actually just using Safari with like Mozilla's branding on it. Safari is the only browser that's allowed on iOS. So, all right, well, if we can't do that, then this whole idea is kind of fucked. And just miracle out of nowhere in August, the Safari team announced that they included Serviceworker. So now we're starting to get, because the momentum had kind of died down a little bit because it was kind of looking like they weren't going to do it, and they have no financial motivation to do that. They make more money off the App Store than they make selling computers. So I think a lot of the hype around PWAs died off for a little bit, but now it's starting to come back that you can do this in Safari. Hey, welcome, Ahmed.
Hey, what's going on?
Not much. We're just getting started. So I don't know if you can see old chats.
I don't think you can in Zoom. Let me check.
Okay.
No.
Nope.
All right. So this is the article that we just read through.
Article.
It's just a summary of the benefits of progressive web apps. And Jared asked, well, if we can do all of these things, doesn't that just sort of replace the need for native applications? And the answer is yes. That's the whole point of it, is that you wouldn't need native apps anymore.
How does this network independence aspect, like how does that work? You have to have some sort of connectivity and communication going on back and forth. Or do you?
Eventually. So think about how native apps work. Where like a lot of them work offline, and even if like it's a news app or a financial stock ticker kind of thing, where like it's not all that useful without network connectivity, it doesn't just crash or show you like a 404 or something if you try to open the app. It goes like, oh, the network can't be reached right now. Or it might say, this is the last known data. Or even like, your connection's kind of shaky right now, FYI. Not sure how current this is. And so the idea of progressive web app is like, why can't we do all of those things? We have the technologies to. And the big thing powering that is Serviceworker, which we'll talk about in the second half of the lesson. Cool, more questions?
Let me read this.
The safety, can you elaborate on what makes it like more safe than like say a native app? Or is it just comparable?
It's comparable. This was basically just Google drawing a line in the sand and saying like, you can't call yourself a progressive web app if you're not using HTTPS. And like, there's a very good reason for that too. Serviceworker is crazy powerful, and if you're like, you can't do not unencrypted traffic through it. Like, that's a terrible idea. So HTTPS is required for Serviceworker, so it's required for progressive web apps.
Okay.
All right, so let me, if you don't mind, I'm going to phrase this to make sure I understand what a progressive web app is. It's anything that's made in the browser that can be used as if it were an app in the App Store, and that you can have a link for it on your like phone, desktop, and do basically anything that an app can do.
You got it. That's it.
So it's completely platform agnostic then as well.
Completely platform agnostic.
Gotcha.
This solves the Sega versus Nintendo problem for software.
So my guess is that Apple is not happy about this.
That's not quite the right way to put it. There are people at Apple like who aren't pumped about this. Frankly, there's people at Google that aren't either. Because Google also makes a shit ton of money off of App Store revenue. And this kind of replaces the need for an App Store. And thus the ability to just shave off a revenue just to have something on your device.
Gotcha.
But both of those are very big organizations, and there's a faction of Google that really drives all of this. Progressive web app is a Google coined term. A lot of these ideas are like either just general things that TC39 or the WhatWG has worked on, or just W3C more broadly. But packaging these all as like one idea is a very Google idea. And to wit, this is from my TechCrunch talk. So I did a history of native apps versus web apps. And so like the big mile marker here is 2010. Steve Jobs says that he's not supporting Flash anymore, and that changed everything. But then like anything interesting about apps kind of slowed down a little bit. Like the next interesting thing was really 3 years later with like the motion coprocessor. So this was saying things like the gyroscope and stuff in the phone have their own dedicated processor, so they don't get bogged down or anything by any other running process. Swift was 2014. It wasn't until 2015 though that native apps got deep linking, which is fucking crazy. Deep linking is like being able to go to a specific page in an app, which on the web we call a link. But with native apps, there isn't necessarily more than one door into the app. And really, so this is 2017 is when I gave the talk, but 2017 was also kind of the last time anything interesting happened with apps, and it was instant apps. Also a Google idea. Also, another part of Google betting against progressive web apps. So the idea of an instant app is a different way to solve the exact same problem. Because apps actually have a pretty terrible UX if you think about it. You go, oh, cool. I want to see your picture on Instagram. So what do? You have to go to a different app, the App Store. You need to look up Instagram. Then you need to download a 400 megabyte fucking monstrosity. And then you wait for that to install. Okay, cool. So then I open up the app. Then I have to make an account. And then once I have the account, now I need to get back to the actual thing that I wanted to see. And so now I need to navigate through the app to try to locate my content. Like, that's a terrible user experience. The way we handle that on the web is, here's a link to my shit, and you just click it and you have it. So instant apps are a different solution to that problem. The idea behind an instant app is you only install the part of the app that's needed for whatever content that you want. So you could send somebody a link to an Instagram content, something like that, and in the background it would only download the parts of that are needed to see exactly what you're seeing. So it's like trying to make the native experience more like a web experience.
Right.
So there's another part of Google that's kind of betting hard on that. And like you see this all the time now. Or rather you don't. It happens kind of invisibly in the background. But if you've noticed you've been able to see app content without installing the app, that's why. The web app side, so Google Docs is really like the first thing I think we would recognize as a web app. But we actually have like a lot of really cool things that happened around the same time. And around 2017, we get progressive web apps, which are a different solution to the same kind of problem.
Wait, so who developed the pieces for the progressive web apps? Kind of like the make an icon on your phone, or you were saying like it used to be a problem that you couldn't store data on a web app. Who is building that out? Is that open source, or is that like a company is working on that?
That's open source. That's part of, I guess that would technically be the WhatWG. So TC39 is the standards committee that works on JavaScript. WhatWG is the standards committee that works on HTML, CSS, and related technologies. So you may have heard me say in a lesson before that fetch isn't a part of JavaScript, which is why it isn't in Node. Fetch is actually part of the browser. So the WhatWG does fetch. They also do Serviceworker. They also do a lot of these like browser-based technologies, and things like the app manifest and Serviceworker are all kind of part of that.
Cool.
More questions about what progressive web apps are, how we use them, that kind of stuff. I feel like Firefox probably doesn't respect manifest, but Chrome might. Okay, so this has a manifest, and in fact, if we go to the source code, you can see it. So a manifest looks like this. So this is what a manifest looks like. You can declare what kinds of icons should show up when you install the app, what it should load into. And if you pull this up on a phone, standalone means that like, even though it's running in a browser, it doesn't look like a browser. There's no URL bar. There's nothing that would indicate that you're using a browser. Nice. And furthermore, when you launch it on your phone while it's loading the page, you actually get like an app loading screen.
Oh, cool.
And it uses your background color and the name of the app by default, but like you can customize that as well.
Oh, nice.
And it's this fucking file. That's it. And you have an installable app.
Yeah, React gives you that for free, right? Or at least the manifest, yeah.
Correct. So let me see what happens if I pull this up in Chrome. This isn't doing it either. If you do it on mobile, it will turn the tab in your browser like a whatever this purple color is, and kind of apps it out a little bit. And it used to be that this was a hidden metric. Chrome finally published theirs. You can't make the user install your app. Like you have to go to the menu and go install Web App Kitchen Sink.
Gotcha.
And it does that. But there you go.
I'll try it.
There's the standalone app.
Wow.
But the browser will prompt a user to install the app if they go to the same URL more than 5 minutes apart. You'll get a little pop-up notification going that says like, would you like to install this?
Gotcha.
I wonder if that installed it here. Yeah, there you go. Check it out on Linux. There's my Web App Kitchen Sink app. Pretty fucking baller.
Yeah.
Yeah, that's real cool.
All you have to do is include this file in your root directory. Done.
Huh. My phone asked me if I wanted to put it on my home screen.
There you go. I think you also need a link to it here.
Actually, and I'm kind of curious what that does.
Yeah, it's this thing, I think. Cool. Other questions about PWAs, what they are, how they work, that kind of thing? Okay. So our first objective was to describe the benefits of PWAs. You run into some asshole at a party and they go, PWAs, I think I've heard about that. Why would I do that instead of just having a native app? I'd like you to write an answer to that. I'm going to give you 3 minutes. You do it by hand. You do it in a Slack message. I would like to see them. 3 minutes. Go. About halfway. All right, why don't you take whatever you have and paste it into the chat, and let's discuss. Doesn't need to be done. All right, PWAs have all of the benefits of a native app without the additional headache of choosing a platform or making something dynamic enough to appear platform agnostic. Anyone can access a PWA since it runs in the browser. PWAs can do everything an app can do, save and store data, be used offline, etc. No need to pay the app store if someone on an Apple phone can use. Yep, all accurate. Cool. Any last things that you want to know about what PWAs are?
I guess I'm curious, what were the last things that needed to be done for progressive web apps to be usable? I think you said it was like offline data storage.
Serviceworker.
Serviceworker.
That was basically it.
Gotcha.
Everything else is there. There's still things being added to this. So for example, when I gave that talk, payments API was like the big cool future thing. And it's still kind of the big cool future thing. Mm-hmm. So we go over to can I use, it's not all the way there yet, payments. So that's where the payment request API is right now. It's actually pretty decent in the desktop browser, but it's abysmal on mobile browsers. So this is a tool for saying, I would like to ask the user for money. And the payments API pulls up that little thing. It's kind of at the bottom of your screen. Like, would you like to buy this book for $5 on Google? And you go, why, yes, I would. So how this works in your app is you go, I would like to ask for money. If they give it to me, then do this. If they don't give it to me, then do this. But that's all you do. Everything else is abstracted out.
Gotcha. And that would be the same as using Stripe. This is just built in.
Yeah, you wouldn't need to use Stripe anymore. You also wouldn't need to ever know a user's credit card number. You wouldn't have liability for any of that.
Nice.
Like all that stuff is just handled by the device.
Gotcha.
The device
so who's
just tells
liable?
you whether or not you got the money.
Gotcha. Wait, so who's handling the liability and the processing for all that?
Google.
Gotcha.
And like realistically, this is probably where they could make back some of that App Store revenue. Is every time you charge them, it is a really nice user experience to just use the payment request API. But this isn't super usable right now because most people have credit cards attached to some like payment profile on their mobile devices. Not that many people do on their desktop devices. So yeah, it doesn't work quite as well.
So getting there. So probably like a couple of years or something like that.
And stuff moves quick. Could be in a year. But yeah, that was like, and one day in the future we'll be able to do this. And now we're getting there. We're making progress. But that's still like kind of what the bleeding edge of this looks like. But that used to be Serviceworker, and Serviceworker is on everything now.
Gotcha.
Was that delay on Serviceworker an engineered delay, in your opinion?
Almost everybody thinks so, including me.
Gotcha. We've so far, based on what we've talked about, I've only read and heard like perks of using PWAs.
Yeah.
Are there any drawbacks?
Yes. Service workers are new and obnoxious as fuck to work with. And it's Like there's some tweet. Let me see if I can find it. Buy new domain service worker. Yep. Here's the tweet. They're kind of dangerous. So, like, you've heard the joke, there's only two hard things in programming: cache and doubt validation and naming things. And off by one errors. Ha, 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 ha. This is the cache and validation part. So what Serviceworker does is it intercepts all of your network requests. And there's like a really awkward but okay enough system for replacing an old Serviceworker with a new one, like as your app changes. Unless you like didn't do it right the first time, in which case like you're just kind of fucked. So that happened to me. So 2 years ago,
with Develop Denver, right?
Develop Denver, nobody would ever see a new version of the site, and so we pushed up a change, and everybody would always see the old one. And it was because of a shitty service worker. And what I ended up doing was I wrote a script that just destroyed any service workers the user had for that domain. And I put it at a slightly different URL. It was developdenver.org/2018 or something like that. And then multiple times blasted the entire address book about cool new things that were happening on the site and trying to get them to go to that URL, which all it did was murder all the service workers and then redirect back to the main site. And this is absolutely like how I feel after having done that. So like that sucks. Also, since it's very primitive, as you'll see in a sec, it's really easy to get wrong, and it's easy to make your app feel janky as hell. And so a lot of UX people were like, PWAs, I used a PWA once and it didn't work for shit. Nano, I did some consulting for them kind of recently about their PWA. And they're like, every time I try to use this other commercial PWA, it just hangs forever. And I had her go through her phone, and it turns out like she turned off permissions for something for that site long ago. Cool. So now when you try to do this thing that requires that, when the service worker is trying to do something that requires that permission, you said no. And you only get one chance to ask a user in the browser. So if you've ever like been on a site and they go, hey, can we have your permission to send you like a so-and-so thing every once in a while? And you click yes in the app, and then your browser asks you the exact same question. The reason for that is your browser only ever asks you once. If you say no, they never ask you again. The app, on the other hand, if you say no there, well, whatever. Then they can just ask you again in an hour, 5 minutes. Who gives a shit? The app's controlling that. But once... So it gets very dangerous. Any user clicks the wrong button on that permissions thing, your app will just kind of weirdly not work sometimes. So like, there's some like growing pains we're going through with this. Cool. Let's talk about service workers. So the concept of a service worker. Actually, let's talk about what a worker is first, because there's two of them in browsers, and they work kind of similarly. So a worker is a background process. There's two of them that we use in browsers: web workers and service workers. There is a decent chance that neither of you have used either of those before. In fact, I'm almost positive. So, but web workers have actually been around a while. Web workers are maybe 5 years old. Let me check. So service workers, pretty good support at this point. Oh, web workers. Yeah, web workers, killer support. So web workers were for really processor intensive things because browser JavaScript single threaded. So that's fine. We have all these async ways that we can handle. You trigger off this thing, and then you go do this thing. Cool. But what if your client needs to do the number crunching? It's not making a request and then just needs to be notified when it comes back. It actually needs to crunch itself. That's where web workers come in. A web worker is a completely separate thread on the CPU. And that it works the same way in that your app considers it asynchronous, but it's still the client actually doing the work. So that's a web worker. A service worker is something that it also runs on a completely separate thread. It's independent from the app itself, but its main job is intercepting network requests. So if this is my client and I am making a fetch request to a server, I get responses. All right, cool. We've done that over and over and over again. Now, what if I have this little guy who sits right here? That's a service worker. It gets a chance to inspect all the traffic going out and go and optionally respond to it directly. So you might ask for a resource that it has cached, and it goes, cool, nope, short circuit. There you go. So this is really good for things like caching. It also happens to be exactly how an offline app needs to work. So if you're offline, you go, oh, shit, don't actually send that request through. I'll just respond to it directly from cache. And that could be some response that you've saved. It could also just be a completely different response that you've stubbed out. Where you send back a message like, sorry, you're offline right now, something like that. You can also let the request still go through and also respond to it immediately. So that might be something like, I'm going to give you the cache version that I have right away. I'm also going to let the request go through, and when it comes back, if it's any different, then I'll just update that. That's what a service worker is. Give me some questions.
Wait, so the service worker is an installed piece of your app?
Kind of. So think about, you know how favicons work?
Yeah.
Your browser is just looking for a favicon. Service worker kind of works the same way, except you say, I would like to register a service worker for this app. And you give it a URL, and it goes, cool, no problem. And it looks that service worker up, and then starts installing it. Gotcha. But since it runs on a different thread, just like web workers do, you can't, it's difficult to directly observe. Because like if you console log something in a service worker, you don't see it in your browser console log. Why would you? It's not part of the app. It's part of a completely separate thing. It just happens to be attached to your app.
Gotcha.
Can service workers also be used as like an additional line of defense on incoming requests or on additional responses, anything like that?
Nope. Not really for that. I mean, I drew this box outside of the client, but really it's inside of the client. It's potentially preventing it from making the network request in the first place.
Okay.
Other questions about what this is?
So I guess that kind of goes on Jared's question then. I can use my service worker to do things before I even hit the server.
Correct. And alley-oop, that's exactly what we're going to do. So I'm going to post an exercise in the chat. All right, go ahead and fork and clone that. So if we run this, okay, cool. So since I was working on this, I have to destroy the service worker. So how you do that, in Chrome, it'll let you do it under the application tab in DevTools. But in Firefox, works totally differently. You go to About Debugging, and then this Firefox, and then you look through the service workers and find yours. So this one's mine, unregister. Cool. So what we want to do is, this says Pikachu all the time. We want to be able to intercept that request and send back Charmander instead. So if we take a look at the app, like, doesn't get much more simple than this. So we have an app.js file, and we have these three elements. That's it.
Cool.
The app.js file, we have something to fetch the Pokemon, we have something to display the Pokemon, we have this capitalized utility, and then it will fetch then display Pokemon when the app first loads. It will also do that every time you click the button.
Yep.
Questions about any of this?
Nope.
So what we want to do is add a service worker to this. So here's what that looks like. From the app standpoint, dirt simple. All that we do is say navigator.serviceworker.register, and then the path to how you get to that service worker. So we'll put one at service-worker.js. Okay, easy enough. So now we need to actually add that service worker, and that's just a file. Service-worker.js. Put it right next to that. It registers over here. Done. That is all of the app's interaction with Service Worker. Now, in practice, it's a good idea to do things like if navigator in, if service worker in navigator, then do this. Because if like somebody's using an old browser or something that doesn't have service worker or something, it'll just go, what the fuck is service worker? Crash, none of the rest of your scripts run. So something like this, since it's supposed to be progressive, if somebody's using something that doesn't have it, it's not supposed to break your app. It's just supposed to not have that feature. It's supposed to not work offline. So in practice, there's like a couple things like this that you would do. But for us, right now, that's enough. And it's a promise, so you can add something to that, to console log. They're like, oh, I registered, whatever. Cool. And that's the end of the app's involvement in this. Our service worker, there's a couple things that we can do here. Most of what we do in a service worker file is listen for events. So your service worker has a couple of parts of its life cycle. It installs. That's an event. It activates. That's also an event. Those two and this is every time you change your service worker, both of those things happen also. One of the things that's kind of interesting about this, and the reason these are two different steps, is that you go, okay, I want to register a service worker. Dope. I want to install. This is a good opportunity to like pre-cache, which is like, I don't even want the user to have to navigate anywhere. I know I want these 20 resources just to be ready to go in cache. So you would do that as a listener, like while you're installing. Activation means that like this service worker is ready to go. Now, here's why like it ends up being sort of a confusing concept, but it's because the service worker runs completely separately from the app. So if I have web app kitchen sync running in one tab, and I also have it running in another, and I also have it running in another, those are three different processes, all of which are completely separate from the service worker. And that's kind of cool. Like there's some neat things that we can do with that. Like for example, since Service Worker runs independent of the app, your app doesn't need to be open for your Service Worker to do shit. So for example, you have your Service Worker, every hour it fetches new news articles and just throws them into cache. So that the next time you open the app, that stuff is just there already, even offline. You can also do shit like you can push like an operating system notification when a new article gets posted, and when you click on it, it opens your app. It's pretty badass. But install happens immediately. Activation happens whenever nobody else is using your old service worker. Because when you update it, you make a new one, you're caching something different than you were before. That's a new service worker, but this one might be on version 3. Those two might be on version 2. Activation happens whenever anything that's using an old service worker is finally closed and over with. Then it's ready to kill off old caches, any of that kind of shit. So once those happen, most of what we're doing is listening for fetch events. Looks like this. So I want to self refers to the service worker in your service worker file. We're going to add an event listener, and maybe for install. Common thing in install is we can actually bypass that, like, all the things need to be closed, by saying self.skipWaiting. Cool. So whenever something's installed, it goes, nope, activate it right away. I don't care if somebody else is using an old one. You can also add an event listener for activate. And a really common thing to do here is once an activation happens, the service worker isn't actually intercepting your request until the next time you navigate to that page. So similarly, we can go, nope, fuck it, do it right away, please. You do that with self.clients.claim. And this will go, nope, I want to use it right away, as soon as it's ready to go. And then we can add event listeners for fetch. Now, a thing that is not immediately obvious about this is that a fetch event is any network event, not just like every time you type fetch in a JavaScript file. So this is your initial navigation. And we would need that for offline, right? I don't even get my initial page load if I need it from a server. So your index.html, maybe you cache that. Your favicon, any static resources like images and stuff. every single one of those is a fetch event. And your API requests and all that kind of stuff. So we're trying to intercept the Pokemon API requests. So maybe what we do is we say if event.request.url, and I want to say like includes pokeapi.co. That's a pretty good use case for a, oh, actually, you know what? We actually do have an includes in here. I was using regex before. Something like that. Then I want to do something. Let's see if we can get that far. So if I go over here, I'm not really going to see much evidence that anything is different until I go over here and I see that this service worker is running. And if I inspect that and refresh again, you're trying to access the Poke API. This is a console just for the service worker.
How do I do that in Chrome?
Chrome's is totally different. So Chrome's is like localhost 3000. So if console is here, application is here, and in this service worker area, you can stop a service worker, you can unregister it,
and this is
get rid of it.
Gotcha. And this service worker is specific for this site.
Correct. All service workers are.
Oh, and I can even see service workers from other origins down below.
Correct.
Oh, whoa, there's a lot of shit down here.
That's every site that you've been to that uses a service worker.
Wow.
There you go.
Does this have anything to do with, and I feel like the answer to this is no, does this have anything to do with how when I'm offline I can still do DOM manipulation on like a local browser or something like that?
No, unrelated. Once the HTML gets turned into the DOM, it's just running on your computer.
Gotcha. But aren't I using the API in order to do DOM manipulation?
Nope.
Gotcha.
Just messing with some code on your browser.
Cool.
I don't know how you would do that in Chrome to like inspect this stuff.
It's just showing up in my regular console, so I don't know if I need to.
Oh, well, that's good. Oh, yep, there it is. Oh, I see. So it's doing it through the service worker there. Got it.
Yeah.
All right. So we're trying to access the Poke API. If we wanted to respond with something different, what you would do is event.respond with. And what this is going to expect is a fetch response object. The good news is you can make your own. You can say new capital R response and pass some object that we want to use as the body.
Ooh, okay.
We also need to, no, I take that back. So we can do that, and then for our body, we actually want to stringify whatever, just like we would if we were making a fetch request. We say json.stringify, like that. And then we can just fake out something that the app would also be totally cool with using. Like name, Charmander, sprites, front, default, and then if we go over to the Poke API and try to get old Charmander, I put that URL in there. All right, now when I try to make requests to that API, it should respond with that instead. Okay, cool. Some I didn't like. Let's see. I'm going to unregister it. Okay. There's Charmander. Pretty fucking cool, right?
Yeah, I want to be like, oh shit.
So as you might imagine, a little bit of a contrived example, but what we end up doing with this is also using this caches API. And how that works is you can open up a cache and then take whatever request was being issued by the browser and whatever response it got and cache that response. And then you can look that request up later, and whatever response it last got, just respond with that immediately.
Mm.
You can also, so pre-caching works by going like, oh, I want you to hit all of these URLs in my app and just cache their responses.
Mm.
And now Match will work with all of those. And then
Wait, so you say that they open up my app while they're online, I cache the entire API response, and then whenever they come back to it, I can just use that API response.
Correct.
However. Jesus.
Yes.
You mentioned earlier needing to replace service workers or that they would be killed off when they're no longer being used.
Correct.
Do you have to manually transfer the functionality that an older service worker was doing or performing into a newer one if you want that to persist?
Kinda. All right, so it works like this. So I have this service worker file, and I go, oh, never mind, I don't want to do that anymore. And so I do that. What happens the next time the app tries to register that service worker? It always tries to do it. And if it's exactly the same, nothing happens. If there's even 1 byte's difference, then it goes, oh, psych, you updated the service worker. Awesome. Let me install it and then activate it. And then as soon as everybody else stops trying to use the old one, then this activate happens, and now we're just using the new one.
Does that automatically kill off the old service worker then?
No, only closing those tabs or something like that. But if you skip waiting, then what you're also saying is all those old tabs, you'll go over and their caches are just gone. And so those might not work anymore. Because usually what you're doing in this activate thing is destroying old caches. So if you go, nope, skip it, fuck it, go right to activation. And you go into activation and blow up all the old caches. Well, if there are tabs that are still using those old caches, now they don't work anymore.
So even though if you had multiple tabs open with the same app, and
Correct.
one of them, if even one of them has a more recent service worker, and you did something like this, even though they're technically independent of one another, because the cache is restricted to that tab, as soon as you update one, it blows out all the rest. If you do this, clients.claim.
No, the cache is per domain, not per tab. That's why.
Okay.
Your service worker is per domain, your cache is per domain. But you have different caches. And so it's pretty common to do something like so you go, I want to open the version 5 cache. I want to delete the version 7 cache or 4 cache or whatever. So they end up being completely separate. You could have them both at the same time, but there's a limit to how much the browser will let you put in there. And so generally speaking, you want to clean up after yourself.
Gotcha. All right, so here's the problem I'm trying to solve.
Mm-hmm.
The TV show API that I'm using right now,
Mm-hmm.
they currently have what I think is a static page because it reloads every time. And so mine, I'm trying to make it more front end heavy so you can do more searching dynamically.
Mm-hmm.
Versus theirs, like every time I do a search for anything, I have to reload the entire fucking page. And so what I wanted to do is cache their entire API response because I'm making like 185 fetch requests. And so is there a way for me to take the cache that I have and check it in the database, or would that be something that I would have to do in the database itself? Is like when my page loads, I send my cache to the database to see if anything has been updated.
Well, for this, you'd be using the cache API for something like this. Mm-hmm. You go, oh, I just requested to my database just like normal, and whatever responses my API gave me, I'm caching those in this browser. And so the next time I can go, oh, I already have that cache. Don't even make the request.
Gotcha. But that's kind of, so I want to decide whether or not the cache matches what's in the API.
Mm-hmm. So how that works is you intercept the request, you make the request, and then you compare the response with the one that you have already.
Gotcha.
That doesn't usually end up saving you anything unless you're responding immediately to the client with whatever you have cached, and then potentially sending the client a message going, oh, psych, I got the one back from the database. It is actually different. And then replacing it then. So then your user gets immediate response and whenever it becomes available, whatever the newest version is.
Gotcha. Very cool. And I guess, because eventually I want to pitch it to them, so I would probably make the first fetch request with what I have cached, so that way the database can decide whether or not to send any new data based on what was cached previously.
You can totally do that.
Rock on. Oh, that's so cool. Holy shit.
I know!
Is there a way to...
Go ahead.
Is there a way to push an updated response to the user without interrupting like UX?
Yep.
Like as they're using the app, just kind of slide it on in?
Absolutely. So how that works, and let me get the survey out. That's with a third API called the client API. So clients are all of the tabs that are currently using a service worker. And so you can get a specific one, you can get all of them, whatever. And then all of those have a method called post message, and you can send it whatever you want. This is how a service worker can talk back to the client, because you can set up an event listener that listens to any message that comes in, and inside of that, you can do whatever. So you post a message and go, oh, psych, API finally resolved. It's got a newer version of this. And in that event listener, you can either swap that out in your Redux store or your Vuex store, or just change it out right away, or whatever you want. Because your service worker can't see the DOM, it can't see your JavaScript scope, it can't see shit. The way that they talk back and forth is through these messages.
That's really cool. Well, and if you're keeping all your keys as the ID of whatever you're getting from the API, then your front-end framework should know what to update on its own.
It should. It never does, because we used to have this in Ember, and then everybody thought it'd be cooler if we did everything by hand. But yeah, the IDs should say, like, oh, I already have this ID, so I have a more recent thing of that. Just clobber it, whatever, same ID. And that should work all the way through your app. Unfortunately, in React and Vue, you have to do all that shit by hand right now. But yes.
I guess I'm not entirely sure what you mean by doing it by hand.
So I have a version of ID5 in my Redux store or whatever. Mm-hmm. Then I make a request to an API, and for ID5, and I get back a thing that's newer. Now what I need to do is look up that thing in Redux by ID and then replace its contents with whatever. You used to just get that shit automatically. As soon as you got back something from that same endpoint and it was different, it would update the store for you.
Gotcha.
Now we have to type all that out. Stupid.
Gotcha. Huh. Wait, is that because it was easier? What's the rationale behind that?
So Ember Data, which was like the big brain behind how it managed all that cool caching stuff, and it could do things like, hey, my base URL for my API is this, and it just guesses in an overridable way what all the rest of your endpoints are. So if you're following RESTful conventions, done. You never need to write out a URL by hand. But if you have something that's just slightly different, or it uses camel case instead of dashes or something like that, all that's overridable also. And it would do things like not even attempt to make a network request if you had recent enough responses from that same endpoint. Everybody thought that was too magical, and why don't we just store all the state for the entire app as one fucking object? And now we have this hell world that we live in, where like client-side data management is such a disaster. Like Redux, Vuex, all these things are like abominations. They're so bad compared to what we used to have. What we used to have is active record on the client.
Whoa.
Yeah.
What? Who would get rid of that?
I know. Like all the rest of the Ember shit, like some of it like is baked into all the frameworks now. Some of the things that like Vue does are honestly kind of nicer than how Ember used to handle those. But my fucking kingdom for Ember Data, it was the shit. You would declare client-side models. You could have relationships between them. It works the exact same way that it does in Rails, where I could say, oh, I want to get this thing's many these, and I want to map through each of those. And I would like you to fetch me updated versions of these. And it'll like go to the API and get new versions and update the backing store, and all that data will react all the way through.
Oh my God.
It was so cool.
That sounds amazing. Now I have to do all that in hand. Okay, now I know what you mean.
Yeah, Ember Data. That's what that shit was. And like I've been hearing this for 5 years, but it's about to be ripped out of Ember, and so you'll be able to use it in anything, but we'll see.
Yeah. Wow.
All right, we got to get to stand down. Any last questions about service workers?
Can we get like a multi-part staff instruction on the Kyle Coberly method for building a progressive web app that is like baller as fuck?
Sure. Also, if you want to work through this exercise, I made a solutions branch.
Oh, cool.
Nice.
So if you go here, you have a solution also. But between that, my notes, and the service worker docs should be enough to get you started on this nightmare world that is service workers. Manifests, delightful. HTTPS, who wouldn't use it? All the new Navigator APIs, awesome and generally easy-ish to use. Service worker is still a shit show. But like, welcome to the bleeding edge of the web, because this is exactly what it looks like.
All right. So service workers are Frankenstein's monster, like round one.
Correct.
Okay.
Awesome. See you guys in stand-up.
Yep. Thank you.
Yep.